So we can work with a lot of GPUs in the same time. I can have several video cards, powerful video cards in my computer, and those video cards need a lot of watts in here. So they need a lot of power that it's produced and provided by those power supplies. So you need to see always how many power your power supply can provide to the other side to see if your video cards, for example, are compatible. The more the powerful your computer is, the more powerful power supply you're gonna need. Scalable link interface, and this is module 3. We're going to talk about this. This is a technology that we can use to have a more than one video cards, right? More than one video cards. Now let's talk about the connectors. We already saw these connectors a little bit on the motherboard. When we talked about the motherboard, we saw the Molex 24, for example, the main one that we have on the motherboard. We have those PCI Express now that we don't have in the old power supplies. They are adapted to new powerful video cards. See that PCI Express 16 connector, 2 times that we can find it on the wires here. The SATA cables. It's not really the SATA cable, it's the power of SATA connector, right? So because of the SATA cable, we saw it here. This is a SATA cable. This is for transferring the data. So mainly we have always one bus for data transfer and the other for the power, right? This coming from the power supply for the energy. So this one gonna connect to your hard drive or optical drive, for example, that work in SATA. And also you're gonna need another cable for data transfer that is connected from the hard drive to the motherboard. That it's a SATA cable. That one is for data SATA cable. And this one is a power of SATA. Those are for EDU connectors, Molex 4, old hard drives, or for example, the fan that we use on the case, right? The fan of the computer, also they are connected on base for Molex, this one, EDU Molex. The P4 is for the CPU. CPUs have 4 pins, P4, black and yellow. We're going to talk about the colors here, what they mean. And you have one connector or sometimes more than one connector. You can have 2. For example, if I have a dual CPU on my motherboard, I have 2 sockets, so I can have 2 times this Molex 4 for each CPU. This is deprecated for floppy. We don't use floppies anymore, right? So we have the SATA ones. So this is the SATA for data. You see that it's plugged here in data. And this is power. So we are talking about this one here, right? We are talking about this one here. It have 15 pins. 15 pins here. If you're going to count them, you're going to find 15 pins. It include +3 and +5 and +12 volt wire. Okay. +3 volt is rarely used by most drives now. So we are more in the +5 and the +12. So the computer, all the computer is based on these 3 values, right? That we find inside on a direct current. So this is the standard voltages that we use inside the computer. We have the 3.3, we have, or just 3, we can say 3, but it's 3.3. We can say 5 can be plus, can be minus, and 12 here can be plus and can be minus depending the component. And this is what the colors mean, right? So the colors are for describing the voltages. We're going to talk about them. So here I have 2 connectors on the hard drive, on the back hard drive. So this is a SATA hard drive. I can see from the connectors here that it's a SATA one. One is coming from the power supply and plug on the back of the optical drive or the hard drive. The SATA one this is power 15, and the other one is for data here, the data transfer, and this one gonna go to the motherboard. So something coming from the power supply to the hard drive in here, and after I have an output or input also in the same time. This is connecting the hard drive to the motherboard. So the power supply is connected to the hard drive with this connector, and the hard drive is connected to the motherboard with this with this connector. 4 pins for the EDU, 4-pin peripheral power connector, Molex connector company, Ampimate and lock. Provide 12 volts and 5 volts. Power for many devices in the computer case, storage device, optical drives, and the fans, right? Use them also for the fans. What is mean here, storage device and optical drives? The ones that they are on EDU, right? So the EDU connectors, they use this power connector, not this one. This one is just for the SATA. But if it's a hard drive based on EDU, so this is the 4 pins that we're gonna connect in there. CPU, we have 4 pins here. You see that we have annotations in there. CPU is showing me that this is gonna go for the CPU. It's using an ATX 12 volts, right? I have 4 pins, 4 of them, and they have their own plug on the motherboard. We saw it on last module when we talked about the motherboard. Additional 12 volt power for older motherboards, and used primarily for a CPU, maybe a Librid ATX V12, P4, or CPU connector, and CADE for the appropriate connector. This is another one. It's also called EPS, 12 volt cable entry level power supply specification. A 4+4 connector include an ATX 12V 4 pins for each one, created to provide 12 volts power for multiple CPUs. You see, I have 2 times this one here when I have multiple CPUs. Okay, so I'm gonna have 2 times the connector of 4 pins, and I will use them both. There is some power supply that they will provide just 1. There's other power supplies that they are adapted to provide 2 in case they will be compatible with the motherboards that they're gonna use 2 connectors of 4 pins. Seen mostly on server or powerful workstation that they work on multiple CPUs. So we have multiple processor in there, multiple sockets, and we're gonna have multiple input for the power for each socket. This is not an 8-pin PCI Express power. You see here, this one, 6 pins of PCI Express. There is some other more powerful that they need 8 pins in some case, right? In some case, you can find those connectors in some power supplies that sometimes they are confused with this double 4 for double CPUs. The other is 8 pins for PCI Express, also for more powerful GPU. Okay, so we can find those for 8. We have 2 CPUs, for example, or we have another 8 that is used instead of the 6 here for some kind of more powerful GPUs, that instead of having 6, we can have 8. But always read the notation in there so you will not be confused, right? So usually it's not here. CPU, when it's PCI, it's not at PCI Express. And here is it. You see the 8 one for PCI Express, but it's 8 instead of 6. Okay, so it's 8 instead of 6. PCI Express additional power for PCI Express adapter, 6 pins, 75 watts, 8 pins for 100. You see, it's a double of it. It's double of it. It's 6. That one provide much more power. 150 watt, provide plus 12 volt, commonly seen on a high power component video adapters. The 8 one is really high performant video cards that sometimes need much more power than those ones. Well, even those ones are really powerful. See, the regular video cards, they don't have any connector coming from the power supply at all. It's just providing the electricity from the main slot of the PCI Express when we plug it in there, right? The regular old video cards, small ones, just a little small circuit, but the big ones, really big ones, they need their own, because the GPU is much more powerful, so they need their own connector, and they are not fed from the motherboard anymore. They are fed directly from the power supply. So those power supply, those PCI Express connectors, they can be 6, they can be 8. It depends on the power that they need. One is providing 75, the other one is providing 150, working both on plus 12 volt. Commonly seen on a high power component video adapters. Some cables have 2 pieces, 6 pin and 2. right? So you can find these two separated. Here they're gonna give 8 the same. Use on both 6 pins and 8 pins connector. So why we separate these two here? To make it compatible with both. So if I have a video card that it work on 6 pins, so I can just separate the 2 and plug the 6. If I have video card much more powerful that need 8, so I can plug the 8 at one time, right? So it's just a matter of making the power supply more compatible with different technology. You can find 2 pins here differently separated, like the Molex 24 here. You see that I have 20 and 4, so 20 and 4 separated, because older motherboard also worked on 20 pins, right? So the Molex was 20 before. So when you find the 4 separated here, it's just more compatibility. So the power supply can work with a motherboard that they need 20, so we can plug this part. If it need 24, it's much more new and powerful, so I can add the 4 also, right? So it's just a matter of more compatibility. Sometimes you can find those pins separated, like here there is almost a lot of video cards need 6, but there is some that they need 8. So sometimes instead of finding 8 in one block, you're going to find 6 plus 2. It's just a matter of compatibility. So I can use 6 if I need 6. If my video card need 8, I already have the 2 ready there, so I can plug them. So the power supply, I don't need to buy another power supply. The power supply is compatible with both, can provide more power if need, or can provide less power if need. Okay, the Molex 24, a main motherboard power. So this one is the main connector for the motherboard. It have 24. Okay, some motherboards have 20 before, right? Provide 3.3 minus 5V and plus and minus 12V. 20 pins connector was the original ATIX standard before. 24 pins was so 4 pins was added for a PCI Express power for the bus, right? So once we included the PCI Express bus in the motherboard, we needed the 4 extra ones. You can connect a 24-pin connector to a 20-pin motherboard. Some cables are 20 plus 4, like this one. Okay, this is what I was talking about. So this is 20 plus 4. And in some other power supply, they are not compatible with both. You're going to find just 20 old ones, or other you're going to find just 24 at once, right? So they are compatible just with the motherboards of 2024. And if you have an old motherboard without a PCI bus, you will not be able to use this power supply, so it's not compatible with, right? So it's just those separated pins is just a matter of more compatibility, so you can use the power supply in a different kind of technology. New NVIDIA graphics support 12 pins connector. The more and more GPUs are more powerful. Of course, here we are talking about the standard. Even when I talked about the power here, it's 1,000 watt. But it's really for a normal simple computer, right? You're going to need much more here, 1,800 or something, to get much more power for GPUs, adapted GPUs. Okay, so it mean need too much power. Yeah, of course. The more pins, the more powers. The more pins, the more powers. I don't know the 12 exactly how many watts it's gonna provide, but of course it's much more than 150. Of course, maybe the double, 300 watt for those CPUs, or 320, something like that. Okay, so this is the connectors we find. Now you see that we have colors for cables here, that they are not just made for the beauty of of the environment and electronic component. They have a meaning that is really useful. I already have a picture here that we can discuss. So you see all the orange things, they are the cables that they provide 3.3. Okay, so the plus 3.3, they are orange. The black are ground. The black, all of them, you can find many of them, they are all ground. Okay, they're the ground. The red are the plus 5. Red are plus 5 volts. So you can find orange, 3.3, black are ground, red are plus 5. The yellow ones, even on the CPU, for example, you see here when I have a Molex 4 for CPU, Here you go. You see, so here I have 12 and ground. Here also PCI Express, I have plus 12 and ground. Okay. And in this one, I have 1 3.3. I have 1 5. Second one 5 here on the back, a little bit red. And also 2 time plus 12 and a ground. Okay. So they have meaning, the colors here. Yellow is plus 12. Orange, another orange here. 3 reds here, for example. Plus 5, plus 5, plus 5. All the black are ground. Now I have some exceptions. The green is the main cable, the main connector, better than cable. It's the main connector that it's gonna provide power for the power supply. So he's the one who's gonna turn on the power supply. He's the one who gonna turn on the power supply. You're gonna always find just one green in there, right? For example, this is a really old trick that we use to see if the power, to test power supply, if it's good or not, or the power supply is dead. So what we do, we're gonna take a paper clip or any connector, right? So we put it here on the green and we put in any other black just to close the circle with the ground, with any ground. And we're gonna plug the power supply to the wall directly without any connectivity to motherboard or whatever. And of course, we're gonna put connection between the green and any other black here using paperclip. And if you're gonna see the fan turning on, so this means that the power supply is good. Okay. If the fan is not turning on, so the problem is on the power supply. Sometimes we use this for troubleshooting. When I have, for example, a power supply and it's plugged to my computer and it doesn't turn on, now I want to know if the problem is on the power supply side or the motherboard side, so I can do this trick to at least separate my problem to see if my power supply is good or not, right? So I will just take a paper clip, ping this green here connected to any other ground, any other black. Is always one green, just one green, and I will just plug my power supply and push the button turn on the back of the power supply here, and I will see if my power supply gonna start or not, right? So I will see the fan turn on here. I will just take here this connector and plug a paper clip between the green and any black, and I will plug it to the outlet, wall outlet, and I will see if the fan is turning, so my power supply is good, right? So it's just a trick, we use it for troubleshooting. The white is the minus 12. Okay. It's there just in case we need some old technology like the ESA slot, for example, working on minus 12 or something like that. Sorry, this is a minus 5 on the minus on the ESA port that's working on minus 5. The blue is providing the minus 12, right? Usually one blue, one white in there. This one is not really used, just in case we have a component that need a minus 5 in there, minus, because you see the reds are all plus 5, so the white is the one who's going to provide that minus 5 in case it needed on some circuits. Blue is providing the minus 12, just one, right? So the yellow are providing the plus 12. This one is minus 12. Power good is for testing the power, is the power is coming in there or not, right? Showing that the power is good when it's connecting this one, saying to the motherboard that we have power in coming from the power supply. And we have usually one purple, is called standby. This is the reverse. This is when the motherboard need to talk to the power supply, it's gonna use this one. Okay. For example, I'm on the idle mode or sleeping, my power supply is sleeping, and the motherboard gonna wake up the power supply to wake up my computer. So I'm gonna need a signal now going from my motherboard to the power supply, right? So from that idle mode that I have on the motherboard, I need a signal in there. So this is all the standby modes. That how my motherboard gonna control my power supply. It's through this Pebble wire that it's working also on a plus 5V like the red ones, but they made it purple because it have a different purpose. Okay, to have a different purpose. So this is all the colors that you're gonna find in your wires on the power supply. So we have grounds always to close the circles on the circuits. So everything gonna end up with the ground somewhere. In each electronical circuit, you're gonna have that ground. We have many of them. They are all black. We have a power on. This is the main one that turn on the power supply, is the green one. Sometimes we use a paper clip or something to connect the green to any black just to troubleshoot our power supply. And we have the orange and yellow and reds. This is for 3.3 and yellow for plus 12 volt and the red for plus 5. We have one white using the minus 5 volt, one blue using a minus 12 volt, gray checking that the power is good, and the purple one is from the motherboard to control the power supply, sending that signal to wake up the power supply, for example, in a idle mode, right? So when the motherboard want to talk to the power supply, it's gonna send the charge in this one to have more control on the power supply. So this is all about the connectors you have in there. Of course, these pictures are available in Google, right? You just got them from Google here. Even this one here for the Omlau. You can just Google Omlau and go to images, and you're gonna find much more, maybe even better images. I just took something basic to explain what I was talking about. All right, now I'm gonna give you the next chapter here, chapter 6, chapter 5, by the way. Let me connect. Here you go. So just please go to Moodle and refresh. You're gonna find chapter 5, BIOS, device manager, IPv6. And you will end up with this document here. It's another PDF. It's called chapter 5. Okay, first part here in this document is BIOS and UEFI. Differences in between. So we already talked a lot about this BIOS, right? Basic input output system. Basic input output system. So who can remind me what the BIOS do? For why we have BIOS? Post, good. So we do post, power on self test. I'm gonna check all the hard drive, and after that, what the BIOS do? Boot the PC. Okay, so you're gonna look for what is the boot sequence that it's configured on, and you're gonna look for booting location, right? It can be USB, it can be CD, depending on the configuration. It can be even the network, the PXE boot, right? So it depends. But he's gonna boot. He's gonna start the sequence of booting. He will go read on that master boot record sectors, MBR, and he will boot. So we have the BIOS, we have the MBR. Where did we saw MBR before? We talked about the MBR somewhere before. Who can remind me where we talked about the MBR? Hard disks. Yeah, good. So when we studied hard disks, we talked about something called MBR and GPT, if you remember. So a master boot record and guide partition table. That is called GPT. What is the difference between MBR and GPT? What was the difference? GPT is better. Yeah, why is better? It's more beautiful? how GPT is better? The amount of storage is more than what? More than what? Be more precise, Toyesh. Yeah, 128 primary partitions. More than 2.2 terabytes. Good. Yuvraj is saying something interesting here. Well, we can say 2 terabytes or 2.2 exactly. So when we are using MBR, it's maximum hard drives that we can see as a storage space on those hard drives are 2.2. So even if you are using bigger hard drives, like for example 10 terabyte, you will be able to use just this space here because of the partitioning all the hard drive, the technology that we are using on MBR, it doesn't have a lot of more addresses available than mapping 2.2 terabytes, right? So we got here, and after we created something called GPT to get rid of this problem, right? A GPT can see much more bigger here, right? You can see some zettabytes or exabytes, right? So we can have much more bigger hard drives. I can see all my 10 terabytes without any problem using GPT. Okay. Now we have a BIOS. BIOS, usually to boot from the OS, where he gonna go to that MBR here. You remember I have MBR, master boot record is just the first sectors that I have on my hard drive, and here the GPT is just the first one. Okay, so BIOS usually he gonna boot the computer. He's the one who's in charge of booting the computer. So what he gonna do? He gonna go and read the instructions here on the MBR, and he will find the operational system here and the sequence of the files, and so go on till I'm gonna get to my Windows. But after this one, we get a problem with. We can't see more than 2.2 terabytes. So we created GPT to see much more. But we get a problem. BIOS is not able to go and read in the GPT to find where is the operational system and boot it. Okay. He can work fine with GPT, but just for mapping. That's it. So he can read the mapping instructions here without any problem. So I can have a hard drive GPT working in a BIOS with a BIOS. That's good. I can put movies inside. I can put documents. I can put game. I can put whatever I want in there. But if I have an operational system, this BIOS is not quite compatible with this GPT stuff to be able to boot this operational system from here. Okay, so we got another solution here. We got something that he can boot this operational system. It's called UEFI, Unified Extensible Firmware Interface. Okay, and since we built this to solve this problem, so we can boot from other OS on GPT, bigger hard drive now. I can have my operational system in much bigger hard drives, and I can boot them without any problem using this UEFI. They did a lot of other improvements. Since we are improving something, they did a lot of other improvements. Okay. Well, first of all, this one is on mode text. In here, they put it graphic things, right? So here, they put it graphic interface. I can use my mouse here, for example, right? It's not just text. I can have in some versions of UEFI some icons, some stats with some design, and so on. So it's like a tiny, small operational system here on top, working on top of the operational system. What this UEFI gonna do? Well, of course, we included all the tasks of the BIOS inside. So it's gonna do the post power on self test first. BIOS UEFI both do that. Now this one is on text mode. This one is on a graphical mode. Of course, this one work on 32 and 64 bits and have some advantage here. I can already put some anti-malware here, scanning my operational system before starting my operational system. I can already start scanning for malwares here. I have something called secure boot, right? That I don't have in this BIOS. Okay, so the BIOS don't really care. All he do is post and find that operational system and and launch the operation system, boot from the operation system. Well, this one, well, he can care now. Before starting this, well, he can use that secure boot to see if there is any intrusion or something in those boot sectors here, so he can check some security here. I have something called secure boot. Okay. Well, this UEFI also, since it's star, it can detect the networking part. So I have all the networking already available here. So I can use remote to UEFI, something that I'm not able to use on the BIOS. So if I have two computers, I will not be able to remote to the BIOS to other computer, because here the networking part is not working yet. There's no yet IP address. I need the full operational system to get the IP address, okay, to get the Ethernet protocols and TCP/IP and those stuff. Well, the UEFI, since it started, it's gonna already start with it all the network side, right? So I already have an IP address. I already have whatever it took to communicate on the network, just in this state of booting with the UEFI, right? So I can remove to UEFI from a distant computer, from one computer to another one. So it's a huge improvement, right? So you see here, it's graphical. I have menus, I have buttons where I can go and click. I have menu, top menu here, button of turning off, and so on. It's just an example. Well, you see the BIOS is just text, right? Text, and all I can use here is my keyboard and the arrows. I'm not even able to use my mouse in the BIOS, right? And this one, I can use the mouse. You see, here's the mouse, tiny mouse. So I can go and select and click and things, okay? So it's much more user-friendly, okay? It's much more user-friendly UEFI than the BIOS. Well, let's see here. So this new standard avoid the limitation of the BIOS. The UEFI framework can boot from drives of 2.2 terabyte or larger. Why? Because this one can boot from 2.2 or smaller, right? So this guy here, he have a limitation because of that MBR. All he can boot from is 2.2. Well, it doesn't mean that the BIOS is not compatible with GPT. It's compatible, but he's not able to boot from it. He's not able to boot from it. If I want to boot from GPT, I need a UEFI, right? So in fact, the theoretical limit is 904 zettabytes that we can have in GPT. Theoretical, still theoretical. We don't have this amount of size in any hard drive yet in the world. This is even bigger than the internet at the time where I read this this article, of course. Or maybe I don't know the size of the internet right now. That's really 3 times the estimated size of all the data of the internet. That's because UEFI used the GPT partition scheme instead of the master boot record. It also boot in more standardized way, launching EFI. Well, this EFI now, it's not really in the hard drives. It's something that is different in different chip. That is executable rather than running code from master boot record to boot. So instead of reading from the master boot record in the hard drive, it's going to go to the EFI and read the execution instruction of booting. EFI can run in 32, 60-bit mode and has more addressable address space than the BIOS, so which means your boot process is faster. Is also mean that the UEFI setup screen can be slicker than the BIOS setting screens, include graphical things. I can use my mouse, can have icons, mouse cursor support. However, this isn't mandatory. Many PCs still ship with the text mode UEFI setting interface. Because when you have UEFI, you can also, in many different kind of UEFI, you can still get access in there on text mode instead of a graphic. UEFI setting interface that look and work like the BIOS setup sequence. So now you have the interface of the BIOS, but you are more configuring the UEFI in the background. It's not really a BIOS. UEFI is packed with other features. It supports secure boot. So this is the scanning malware before booting the operational system, check for validity to ensure no malware has tampered with the boot process. It can support networking, so I can remove from one computer to the UEFI of another computer if the networking is enabled. Okay. It's not just a BIOS replacement either. UEFI is essentially a tiny operational system that runs on top of PC's firmware, right? So we still have that kind of firmware that you're gonna do the post and bootstrap and something, but it's a fully operational system running on top of that firmware. This is why we have that graphical things and recognize the networking in the same time, having an anti-malware for a secure boot and so on. And it can do a lot of more than a BIOS. It may be stored in a flash memory on the motherboard, or it may be loaded from a hard drive or a network share at the boot. Different PCs with a different UEFI will have a different interface and features, of course. It depends on the computer and the manufacturer. A function, it do the post, it do the bootstrap, the same thing as a BIOS. BIOS software driver, dealing with the drivers, and CMOS setup configuration program, which allow to configure hardware setting. We already talked with this like many times and explained what is the difference between CMOS setup and the BIOS. To enter a CMOS setup, you must press specific keys just after we turn on the computer, like delete, escape, F2, F1, F4. It depends on the computer. Usually, it's gonna show you on the first screen, like here, for example. You see, press del to run setup. So in this one, this is a BIOS based on American Megatrend. We have Phoenix also. We have AMI BIOS, that AMI awards BIOS and American Megatrend like work together and merged. They build the AMI BIOS for American Megatrend and awards, AMI awards BIOS. Or combined mini keys, so you can have some weird situations where the computers need a combination of keys to go to that setup. In some versions of UEFI or BIOS, we can custom this, right? So we can go there and configure how we can get in there to get more security or something in companies, for example, right? BIOS manufacturers, so we have American Megatrend, Phoenix, and Awards. Well, there is others, but those are the main ones in the world that they produced BIOS. Those ones, of course, as I said, they merge, right? So American Megatrend and Awards, they merge to AMI Awards, AMI BIOS or AMI Awards BIOS. And we have a Phoenix one. The main menu, the main BIOS menu, you're gonna find main, advanced, power, boot, tools, and exit, usually, right? So main, tweaker for tweaking all the PCs and voltages, doing some doing some improvement with the frequencies or whatever. So overclocking, we call it, basically. Advanced and power and boot have more informations. In the main, you're gonna find system time, so it's the regular time, system date, legacy diskette. Diskette is the floppy here. That's where you can see this, all the BIOS in old computer. I can see from here that I have 6 SATA ports in my motherboard. I can see that I have 2 things that they are plugged in SATA 1 and SATA 2, and all the others are free. SATA 1 is plugged to Western Digital hard drive, and this one is plugged to a optical drive, since I can see here a DVD. As you can see, DVD. So in this computer, I have 1 hard drive, Western Digital hard drive, and I can have an optical drive, 1 CD-ROM optical drive. Okay. Always in the left side, you're going to find the instructions how you can navigate on this. So you're going to say select screen, select item, using plus and minus to change fields. On the lists, for example, put in something first, put in something further. F1 having general help. You can select something on tap and exit with escape, exit page, and go to the earlier page. If you want to exit and save, exit the BIOS and save the changes, you just press F10. So this is an American Megatrend. And we have some, well, here I put it some list of some configuration, kind of configuration I can find of BIOS, but a lot of other things we can configure from BIOS. This is just some examples that I put it here to give you an idea what we can find in BIOS, things that we can find in BIOS. But there is a lot of other things, and it differ also from a computer to computer, from a motherboard to motherboard, from version of BIOS to version of BIOS, and so go on. Okay. So LBA, for example, we can see LBA, logical block addressing, is a method of addressing. We talked about it when we talked about the hard drive. What is the other method of mapping a hard drive? So we have LBA and CHS. Yeah, good, Malawar. Right. We have cylinder, heat, and sectors. CHS. Okay, so the maximum of capacity is 137 gigabyte. The optimal is auto. So we can check here for the logical and do some changes. DMA, direct memory access. We saw also this before. It's a, what is this bus used for? DMA, something related to IRQ. Come on, guys. I see people that they don't review their course. The processor want to communicate direct with the memory. No, me too. Not at all. Wrong direction here. Graphic, no. Without involving processor. Yeah, you've right. So when the devices or the component want to talk with the RAM directly, with the memory directly, right, without evolving processor or interrupting the processor, they know what to do in the memory, reading something or writing something, so they can get access to the memory directly using this bus, direct memory access, or a DMA, right? So when devices want to interrupt the CPU, what they use? Devices or component that want to interrupt the CPU, what they use? IRQ, right? Interruption request. And when the CPU want to talk with the devices and component, what he gonna use? Now the other direction from the CPU to the rest. Come on. Nobody is trying. We saw three kind of communication with this last time. So the DMA going straight to the RAM or memory. We saw the IRQs interrupting the CPU. File S? Girdhar, I don't know what you're talking about by file S. Now from the CPU to the rest, what is the third one? What is the third one? EPI? No. EPI is internal processing interruptions. When the CPU want to interrupt the CPU. EO channel, good. Input output channel, right? Or input output range, or input output addresses. Gurvir, it's not PCI. Come on. Input output addresses, or input output range. This is going from the CPU to the input outputs. From the input outputs to the CPU, this is IRQ. Okay. Well, there is a lot of other IRQs can even be based on softwares, right? Softwares can interrupt CPUs also. Task gates. Right, so you need to review, guys, right? You need to review things here. Here is an example also of a page of advanced. You can see that I can see the manufacturer of my CPU, that is Intel. It's a Core Quad CPU. This is the model of my CPU. The frequencies, 2.5 gigahertz. Uh, this is an old one based on FSB. What is the FSB? We talked about the FSB. What was the FSB? What was the FSB? Frontside bus, good. So it was the bus connecting the CPU to the memory before, right? Frontside bus having a 1333 megahertz of speed. Now this FSB is replaced by what exactly? HTTP, that stands for what? HTTPS? What is HTTP? It's kind of a bicycle like VTT. What is HTTP? Harmander. Hypertransport bus, right? Hypertransport is for Intel or for AMD? AMD, good. So what is the particularity of that hypertransport? Why is good? What is the specificity of that? Full duplex, good, Mitwa, good. Full duplex, right? So can communicate in the same time in both directions. And the same concept on Intel, what we call it? High bandwidth and low latency, yeah. Novi, good. Quick path interconnect. Okay, good. Quick path interconnect is QPI for the Intel. Okay, now this is all technology FSP, front side bus. Can see also the size of my caches. You see that I'm not having here in any L3 level. I have just cache L1 and L2, 128 kilobyte for this one. And you see L2 is much more bigger. It's 4 megabytes here. Which one is faster than the other one? L1 is faster, right? So this is smaller is the faster here. L2 is bigger and a little bit slower, right? Ratio statue for an unlocked minimum maximum ratio, something related to the electricity, maybe, I don't know, ratio value, CPU ID. This is the ID of the CPU. And we have other custom options here that we're gonna see one by one here on the list. And one that is really important that I want to talk with you here is this. See, it's something called Intel Virtualization Tech. Well, you can find it in other kind of description, other words I mean, but it's the same thing. Virtualization. So all the CPUs that they support virtualization, they're gonna have this option in their BIOS to enable it or disable it. If this one is disabled, you will not be able to create virtual machines or use any virtualization in there on that machine. Okay. For example, when you RDP to the school computers, well, this option in the UEFI is enabled in there, right? This is going to let you use Hyper-V, for example. Okay, so when you disable it, it will not work. When you buy a computer and you want to know if it support virtualization or not, well, you need to see the model of the CPU if it support the virtualization. And sometimes that virtualization will not work at the first time. So you go to your UEFI or BIOS and you enable it to make it work. Okay. Here you go. SATA configuration, enhanced, compatible, disable. So I can disable port of SATA here, right? So I can come here and put it disabled. So even if I plug something, it will not work anymore, right? VTD in the latest one, where I don't know what you're talking about. VTD. What do you mean? Just explain it. I'm not Google, right? CPU ratio setting, change the frequency multiplier of the processor. Well, this is usually what we use for overclocking. But what is overclocking? Overclocking is when we play with the voltages and the frequencies to push the component to work the maximum efficiency possible in there, right? So imagine, for example, I have one guy that is working in the manufactory, and he can lift till 40 kilo or 40 pound. So this is the maximum that he can have. But sometimes when he work, he can go with 15 at the time and go back and take 20. Well, if I'm gonna overclock that guy, I'm gonna tell him that in each chip, he's gonna take that 40. It's the maximum, right? So the CPU have some maximum voltage, the RAM have some maximum roundment, right? Well, we can play with these voltages to make the computer working on the maximum power every time, right? It's good for gaming. Usually the gaming computers that we overclock them, but it's some dangerous process. If you don't know what you are doing in there, you can burn your motherboard or your CPU easily, right? So it needs some instructions and having some ideas before going and just jumping on that overclocking process, right? So CPU ratio setting, virtualization, yeah, okay, using the maximum power of any processor. Exactly, Bharat. CIE support, it automatically reduces CPU multiplier, slows CPU down when the computer isn't doing much. You see, this is good for saving electricity, for example. So if this is enabled, when there's not a lot of things to do, well, the CPU gonna lower the CPU multiplier, right? So we're gonna like reduce it automatically, so it's slow the consumption of the energy. It's a way to save power, for example. So I can enable it, disable it, whatever. Intel virtualization tag, C-state tag, allow the OS independently lower the frequency of the core when it's for saving power. So we'll lower the frequency of the cores inside the CPU, and it's controlled by the operational system. Front panel type for the HD audio here, I see, so I can just go to that HD audio and enable it, disable it, or change it. Here is the FireWire, enable, disable FireWire, onboard LAN controller for network connectors that I can enable, disable onboard LAN boot ROM, allow the boot from the network or not, the Pixie one. USB functions, I can disable the port of the USB 2.0 if I have USB 2.0 controller there for compatibility. Higher the speed, use full speed or high speed, that can increase and low. Full speed is always the same speed at the higher speed. I can see that I don't have in these examples here USB 3.0. USB EHCI controller, enhanced host controller interface peripheral. Give more information about them to the OS, like brand and model, so I can disable it or enable it, so the operational system can know much more about my controller interfaces. And usually also we refer this EHCI. I don't have a lot of details about it, of course, but something that also, if we have a computer that is compatible with reading on the magnetic drives, right? Of course, so I'm talking about the magnetic, when we have a magnetic drives. So it's something that sometimes you see the heat here, and I have tracks, right? I have tracks. And sometimes the heat here, well, it's replaced now. This is really old thing that I read before. But just to give you the idea, here we have a spot here to cancel going up or down, like on the tracks. So this heat gonna move through those kind of doors, right? for mapping and going to different sectors on there. But when we use this HCI thing on the older hard drive, of course, I told you now, of course, everything changed. This he can move wherever he want, like getting free things and just going from sectors to sectors, reading much more faster. Of course, but you need a compatibility for that. I saw many computers don't boot in because of they were on the BIOS on HCI mode, and we go there and just turn them on the EDU, and they will working on this kind of logic of EDU back. Full screen logo, enable, disable to show quick boot. The quick boot when enable computer bypass showing the start and boot process, so we will see nothing and just go to Windows directly. And full screen logo is just disabling this kind of logos. You see the logos on entry, having other options, for example, display this image or not at all. This is just some few examples, right? It's different from one environment to another one, just to give you an idea of the kind of configurations that we can find in there. It doesn't mean that you're going to find this in any BIOS that you're going to deal with. Boot up numlock on off. Well, this is something also that it's sometimes useful. You see that, for example, when I boot my computer, I have the numlock here on or off, right? So I can tell my computer if when you start, you put it by default on or you put it by default off, right? I saw some BIOS also. You can turn on your computer by some combination of keys in the keyboard, right? Pressing control space or something like that, and your computer is going to go down, or you're going to turn on your computer with some keys on the keyboard. You can also in some BIOS have further configurations as those kind of configurations. It's advanced configurations, mostly about your hardware, connectors, speed, frequencies, voltages, and so on. And of course, also we have this part here. Where's the list? Boot that is really useful. Usually when we deal with the BIOS, here's where we go and change things, right? So here I can here's where I can configure the boot sequence. Like, for example, if my computer gonna boot, I want him to check first my optical drive. So something already in the optical drive that it's bootable, he will not even check all the things. He will not even go to my hard drive. He will just boot from there. Right? If there is nothing, he will go to the second available option. My second available option, for example, going to be USB. So check USBs. If you find something bootable in the USBs, boot from it. If you don't find, go to the next one. What is the next one? I'm going to put my hard drive. So it's something that it's custom. I can, for example, put my hard drive first. So he will just always go to the hard drive and find if there is any operational system in there. Okay, he's gonna boot. He will just ignore all the others. All right. So the boot sequence, it's usually configured from this boot menu. Tools, here we find how we can upgrade and update our new versions of BIOS if it's available. Okay, usually we find it on this this tool. Device manager. Let's go to computer now. See device manager a little bit. Just a review because we already dealt with the device manager. Okay. So device manager is usually where I go to update my drivers, if you remember. Well, I used it last time when we were looking for ERQ somewhere in our computer. So if I go here and go to properties and click here in device manager. So from here, I can see all the peripherals that they are connected to my computer. I can see microcontrollers, whatever. If I add printer, it's gonna show here. Used also for troubleshooting, because if I have any problem with any driver or any device that it's not really connected or recognized with my computer, so I can see that something is connected here, but it's gonna put a yellow question mark on it, saying that something is wrong with this driver here, right? So we use it also to troubleshoot. We can update drivers from here for any component. Is just to go into driver and update driver. Okay, update driver if I have any other available, so I can search on the internet, or I can do it locally if I already have a driver on CD-ROM or USB, so I can choose the file and just update the driver. Or I can look on the internet, search automatically for update, and he will go to the internet and see if there is any available upgrade for that driver. All right. Details. We have hardware IDs here, I guess, if I remember. Well, you can check it on the document. It's hardware. Yeah, hardware IDs. Hardware IDs is useful also when you are looking for a driver of something on. It's not maybe in all the component. Where is it? See, so you see that I can take now those references and try to go deeper in the internet, trying to find a driver of something from the manufacturers. Sometimes also they are available. And you're going to find it much more easier with these IDs here, right? Referencing exactly to the circuit or whatever controller you're looking for. So we can use this better. So it's just more informations here, right? You see driver date, it was on 6/21/2006 that it was produced. Info section, hyper video install. I can have a lot of informations that they can be useful in these details. Here, compatibility, compatible IDs, and so on and so on. Resources, of course, I can see the memory range. I can see the IRQ here, right? Some displays. This is a virtual machine, so we don't have much real things. But I showed you last time, we found one, I don't remember which one, that showing the IRQ here. You can see it on the document here as an example on the images. Here is it. So for the PS2, for the keyboard, right, it's showing the input-output range addresses. So when the CPU want to talk to the keyboard, this is the range of addresses that you use. And when the keyboard is talking to the CPU, you have the priority 1. What is the 0? ERQ0, what is it? When we use the peak first, we get 16, right? From 0 to 15. After we use APIC for advanced programmable, and we get a lot of other addresses now, but still the priority from 0, 1, and after 9, and after we go back to 2. We saw the schema of that last time. So as I told you last time, our keyboard is always the number 1, but we have 0 before. What was the V0 one? So what is the thing that have more priority than the keyboard? In the regular IRQ, of course, we saw that we have other IRQs that they are VIP. Well, I'm not talking about those ones, the NMI one, but in the regular one from 0 to 15, for example, in the peak, we had the 0 one. What was the 0 one? Master? Master what? What master? System timer sheet. Good. It's the timer, right? Timer have priority over all the others. Okay, the timer for the clock on the CPU and the frequency. When that clock want to get to the CPU, it go first. After is the instruction coming from the keyboard that they have the IRQ1, right? So you see that it's IRQ1 here. Of course, all these informations can be displayed on MS-Info32. We used this last time also. I showed you MS-Info32. MS-Info32. And we get here and we can go and check our hardware, for example, system summary. I can see Microsoft 10 Enterprise. This is the version. Based on what 64 bits. This is my processor, so we can have a lot of information. BIOS mode, it's a UEFI virtualization, of course, and I can see here my ARQs. You can show me some because I told you I'm on a virtual machine, so it's not really good. This is my channel DMA. It's showing nothing here. Virtual machine, of course. For the hardware and input-output range. This is a real-time clock that is showing here, but not showing all the things. But if you're going to do it in real computer, of course, you're going to have much more full informations here. And those are informations about all the components. See, modem, network, adapters. So I can see the model of my adapters here. Protocols that they are enabled or not. The WinSock is the library. Where is it? Where is target? The library of the networking on my operational system. My display, right? So Microsoft Hyper-V video is virtual machines, not the real display. Sound device and so on. CD-ROM, some information about CD-ROM here, the optical drive. Problem devices. If I had any error, I can printing. If I have printers, the storage, the drives, the disks, SCSI. Of course, I have SCSI, and this is the file where it's stored in my computer, dealing with this SCSI controller here on the setting, and so on and so on. So this is this MS-Info is really useful, and also the device manager for updating driver. Usually, this is why we use it. So it's just right-click and update driver, or we can double-click and go to drivers and click on update. Right? I can remove a driver, install driver, and install device completely here, so it will not be recognized anymore, and I will reinstall it again. Okay, but usually when you have any conflict or problem, you're gonna see here a yellow question mark on top of it. Something weird. This device is not working well. Okay, this device is not working well. This is about the device manager. Now let's go do another thing. So you remember the NTFS have some property over FAT. When I have an NTFS, so here's my, well, let's add a hard drive here and add a partition, create well, maybe I already have some space that I didn't use. So we create just a simple NTFS partition. I can delete the others that I don't need them. No matter, I will add a hard drive. Here you go. I have a lot of space here. So in this drive here, so a new sample volume, and I will create just an NTFS one, sample one, or on letter F. Next and finish. And you remember the properties of the NTFS. We had many other properties. So what was the main property of the NTFS compared to the FAT? Who can remind me that? Security, Malhar, good. Yeah, the security was the main one because we have this security tell the level of the file or the folder, so we can go on security and configure, modify, read, who can have access or not. It's something that we can do on the FAT. Well, when we create something here, so I'm going to create a folder, for example. I'm going to create a file here. So this is my folder. This is a regular, right? So this is a regular folder. I'm going to just call it regular. This is a regular file. It's just regular. Okay. Now let's create another two folder. I'm going to call it comp. And another file. I'm going to call it comp. And another folder that I'm going to call Anchor or Encrypt for Encrypt, or call it Encrypt, and the file here for Encrypt, right? So I have regular, Well, this is not compressed yet. I just named it compressed. But if I go to properties here, so if I click on advanced, you see that I can compress content to save disk space. So I can compress this folder here. Here we go. See, now I have something showing here on the icon, on the corner of the icon on blue, saying that this is a compressed folder. I can do it for a file. So I can go to File Property Advanced, and I can compress a file. Here we go. The same symbol on the top corner, little blue arrows showing on the corner saying that this is a compressed one. Okay, I can go and encrypt something. So encrypt content, and it will be encrypted. Okay, here we go. Well, here it should show something yellow, but we are not able to see it because the icon is already yellow. All right, so yellow on top of yellow, we are not able to see it, but we can see it on the file. So look at the file one. I'm going to encrypt it, advanced, encrypt. Here we go. You see in the corner here, I have some kind of asterisk, a yellow one, right here on top of the corner, saying that this is an encrypted file. Right. Well, let's create another file here. And I will go here and go to advanced. I will try to compress and encrypt in the same time. Look, I'm not able to do that. So it should be encrypted or it should be compressed, one of them, but not encrypted and compressed with just the utility of Windows. So I'm trying to select both. I'm not able to do that. Okay. We talked about compression, we talked about encryption, but encryption is going to come on the module 4 with the big chapter of what is really encryption and how those things happen and the type of encryption. We're going to talk about all this on module 4. So in Windows, having NTFS partition, I can have regular things, I can have compressed things, I can have encrypted things, right? Now, I did this, and I'm going to stop here with this encryption and things. You have this screenshot here showing the same thing that I did there, right? So NTFS, you have encrypted and compressed and regular things. After, of course, after I'm going to give you a work, what I'm going to ask you to do is to take each kind of file or folder file and copy it on different folders. So for example, if you're going to take a compressed file and you're going to copy it on encrypted folder, what's going to happen to that file? If you're going to take a regular file and copy it on compressed folder, what's going to happen to that, right? So this is another work, and we're going to talk about it, of course, when we do the correction of the next assignment that I'm going to give you. We're going to do it together and see it, but I'm going to give you that work before doing it. So this is like kind of table. I have a folder, I have file result, and they have the file of the beginning. I have uncompressed, compressed. So uncompressed, when I put it in compressed, what it's going to give me. Compressed, when I'm going to put it on compressed, of course it's going to stay compressed, or maybe, I don't know, maybe it's going to explode. Right? So you just do this experiment after, give you time to see what's going to change, and if we're going to see some kind of pattern in there or having some kind of general roles, we're going to talk about it, of course, once you're going to do that. Right, now let's go to backup and restore. Well, because we don't have time, it's 12, almost 12 here. I don't want to start backup and stop it, and neither IPv6 and stop it in 10 minutes. So what we're going to do, we're going to take our break of 1 hour here. It's 12, right? And we're going to come back in 1 hour, right? So it's lunch time here. We're going to take rest with TAs. You're going to take some rest. And after, we're going to come back at 1 o'clock, and we will still have 3 other extra hours. We'll do some extra other stuff, and after we'll stop and give you some work, and we will continue and finish everything tomorrow when we met up tomorrow, of course. So take some rest. We have 1 hour, right? So we're gonna come back at 1 o'clock, 1 minus 10, something like that. We're gonna take 1 hour of a little break, eat something, take some rest, and come back, of course. Okay, I will, of course, notify you on Kaizala. I will not really disconnect my Zoom here. I will just disable my camera and my audio. But before going